So good afternoon and welcome to today's webinar, Is Your Data Safe in the Cloud?, sponsored by Symantec. Before I introduce you to today's webinar speakers and give you a little bit of background on Symantec, I'm going to do a couple housekeeping items. Number one, this webinar is being recorded, so it will be available in an archived edition in about 2 business days. You will also get an email in the 2 business days with a copy of this recording and a copy of the slides for today's presentation. The second piece of housekeeping information, if you have any questions, there is a Q&A section at the end of this webinar, so please use the chat or Q&A box on the right-hand side of your screen to ask those questions, and we will use them at the end of the presentation. So about our speakers today, we've got Glen Bellomy is a technical architect, information management, and public sector strategic programs. And we also have Tom Tittermary, who's a technical architect, information management, and public sector strategic programs, both of which work for Symantec. They can give more updates on themselves if they need to. Also, here's a little slide about Symantec, but Symantec is a global leader in providing security, storage, and systems management solutions to help consumers and organizations secure and manage their information-driven world. Our software and services protect against more risks at more points, more completely and efficiently, enabling confidence wherever information is used or stored. And if you want to continue that conversation, that is where you use that URL. So now I'm going to pass things off to Glen, and Glen will take it from here.
Good afternoon, Liz. Thank you very much, and welcome to the audience. This is an interesting area and an interesting time that we live in, both the area being the cloud and then the time being the evolution of technology. As we look around us, we see a lot of transition that's happening, heavily driven by technology, but also driven by our desire to be more aware of what's around us. As we look at the educational structures, particularly, we find that there is a rapid transition to more proactive use of the senses, especially the hands, the eyes, and the ears in the educational world. And our kids are really learning, and I say kids because I don't know what the age is out there, but our students are learning at a very fast rate how to use their multiple skills and multiplex themselves in ways that challenge some of the old conventional styles of education. And as we look at it, the web-powered app is clearly a leader in driving us to the cloud. We saw that with gaming. We see that with our TV and video programs. And so as we move into the academic discussions and actually into government and into commercial worlds, we see that the web-powered apps are really important. Now, how does that awareness translate into a technology evolution of why is cloud important? What happens is that as we begin to make our resources more flexible, our devices available, we've also saw the increase in network demand. One of the old sayings is, I wish I had $1 for every network upgrade that we did, because all of the networks have had to constantly be upgraded. And you can go through our home appliances, you can go through our modes of entertainment, and you'll see that the evolution has been around the technology driving things that are common to us. And we're seeing this very heavily in education, and the web-powered apps give us a beautiful place to start the discussion around clouds, because they give us the ability to take that network performance, put it out into a structure where that we as a entity, being a university or being a school, don't have to worry about how that application gets delivered in its final form, but we just get it up and then we let them somebody else worry about the bandwidth, rather than all having to come to our schools or our local site. The web-powered apps is really powerful because it gets us the ability to take advantage of bandwidth that we never thought we'd have in local communities. The other one is, in the web-powered discussion of clouds, is we begin to take the applications and host them through a common structure. and it takes the general access away from our data center. So more and more hosting of web apps, front ends, and then data structures on the back end give us more flexibility in the data center if you're into the data center component of this. And then I guess the next thing that's really driving the cloud definition is the fact that we can set up and test our total operation, a complete application, in a cloud-like environment or in a full cloud environment without having to make capital investment. In the past, we would spend 2 years getting our infrastructure purchased and testing it and making sure it's right. And once we made that investment, we had very few options in changing. Today, we can go out, stage a application in a web environment, in a web-hosted environment, validate that it's what we want, and then we can turn it on, or we can turn it off. And we've never made a real capital investment in that process. So we're seeing a lot faster development because of that infrastructure. Next is virtualization and replication standardization. In the past, the concept of having a consolidated server, if you would, that I can move from one machine to the next in a virtual way, that was not possible. So today's technology is to encapsulate everything into a virtualized container, and now then be able to quickly move it where I want it. So I can start with a small engine and move it to a larger engine as I need to, or vice versa. So that capability or flexibility of movement gives me that capital leverage that says I don't have to start with the size of the biggest size to make sure I accommodate it, but I can right size it today and move it tomorrow. And then the next one is the fact that it doesn't matter whether I'm deep in the data center as an administrator or if I'm at the senior management level. Storage requirements are the big unknown factor because they're growing absolutely so fast on a yearly basis. It's 3x kind of discussion for a lot of sites in terms of how much storage do they need. So building an infrastructure and a building and a facility that will accommodate 3- and 5-year planning becomes very tough. So by having the ability to offload some of that fast storage growth into a cloud structure gives me a lot more flexibility around what I have to do in my data center. So leveraging that low-cost online access is very powerful for those things where I don't have a high-demand, high-performance requirement. So I can actually leverage my storage that I currently have in my data center by offloading some of that resource into the cloud. At the same time, I can look at the cloud as a resource for backup and an opportunity to take some of the tasks that I would in the past put on tape and moved with the man in the van kind of discussion. I can now move that into the cloud and make it an intermediate storage area for me in terms of being able to accommodate additional backups that the data growth itself requires. So at this time, I'll pause and ask if there are any particular questions that might have shown up. Liz, have you seen any questions?
Not yet.
Okay, that's not all bad. As we move forward, we ask ourselves what's causing us to move into the cloud, and then we turn and look at what are some of the most common uses that happen and that drive us and keep us in the cloud. One of the first things that moved out there was the email services. Email services in two different ways. One was the ability to archive information off of the backside of email, just the old mail, if you would. And the other one was simply to get the mail services up into the cloud so that we were not having to run cloud services in a local data center. So the email application was a great place because of its common mail transport protocol, was a great place for us to start with a focused application and put it into the cloud. So we now all have different forms of Gmail or some form of online mail services. The other critical component there was the file server. Simply being able to build a data structure out there that would grow as we needed it was really important to the definition of the cloud. If you think about it, Dropbox is probably one of the most popular earlier adopters that we had, simply to share objects. If you think about what we do with Facebook, what we do with the different types of LinkedIn, et cetera, you see that they're really about repositories of information that can be quickly disseminated to a larger audience. So file servers gave us that capability, whether we were talking about storing private information for manipulation, or whether we were talking about sharing information among audiences. So those were two of the first drivers. The other thing in the academic space is the library. If you go back to the 90s, the library was one of the early drivers of some of the internet distributions, because the library, whether it was the general library in a university or whether it was a public library, got funding from the federal government for internet expansion. And the first thing we put out there was the indices for journals and periodicals, and because it was a constantly growing and dynamic thing. And so we went from that kind of world into a more and more applications world, where we went from the abstracts to the full journals online, to books online, and now then we have our courses online, et cetera. So you can see how just having the repository and being able to access it in those open ways gave us a very large growth. And it started building what we think of today as the clouds, or online access. And with that, I think I'll turn it over to my partner here, Tom, and let him talk a little bit about what they're looking to store in those clouds.
Thanks, Glenn. Yeah, it's funny. I was actually having an interesting conversation with, I have a 6-year-old and 8-year-old, 2 girls at home, and I was having a fascinating time explaining to them when I was younger, having to find information and going to the library and finding the card catalog, potentially going to the microfilm to find the old archived copies of newspapers, then having to explain what a newspaper was. It's funny that both of my kids are growing up fully digital, and they expect to be able to have access to all data and all things at all times and all places. And one of the things that I've been doing as part of the public sector and working with some of this cloud stuff is kind of talking about, to government agencies specifically, I tend to work on federal, having a better understanding of their data, and then making determinations around whether or not that's data that they think is cloud viable or cloud worthy. So I'm not wanting to read directly from the slide, but different things that schools are looking to store in the cloud. So a couple of areas where I would provide a little bit of insight or caution. So another interesting thing is I actually, before I got into IT, I was a high school teacher myself in Northern Virginia. And I see interesting corollaries between, one, as somebody who works in IT, not being able to understand or knowing in advance what an end user is going to do with an application or technology that I hand them. It can go off in crazy directions. And students in particular, given my experience from being in the high school arena, you don't always know, given materials and tools, what end users of an individual application are going to do. And as administrators, as educators, there's often a responsibility with a potentially younger audience in some cases to give them some guidance or some protections around making sure that the technology is being used in an appropriate way. A couple of things I'll say around this. There was a gentleman I've worked with in some federal programs. His name's Kevin Jackson. He does a lot of federal cloud work. And a quote that he said that I'll never forget is, if there's a piece of data that you are looking to place in a cloud platform for which the provider cannot adequately financially compensate you for its loss or breach, in terms of they couldn't cut you a check to say, hey, sorry about the breach, here's the money that will take care of that breach, in terms of the pain you felt, then that is not cloud viable data. So I noticed a couple universities in the attendee list. If there's a couple of government program co-research opportunities going on that might have some international traffic and arms regulation, ITAR compliance, US citizen requirements around it, interesting things in that category, if there is sensitive PII that you are unsure of the individual cloud service and the security restrictions around it in terms of how they will protect that data, that's definitely something to investigate. And in a lot of cases, different clouds will have different contractual terms to exactly what security they're providing in-house, what security is your responsibility, and such and so forth. But you know, in terms of what schools are looking to store in the cloud, list here, and a little bit of guidance, I would say, in terms of, have a firm understanding of your own data before you approach the cloud question. Glenn, if you could, or can I hit next here? I believe I can. There we go. So key technical issues to consider when using cloud for data storage. So some of the real mechanical things, getting data in, getting data out. So one of the reasons, and Glenn very aptly put it, for utilizing cloud services to be able to burst into cloud, being able to offload that infrastructure into a larger infrastructure, into somebody else's infrastructure. And we're seeing larger and larger platforms for data storage. I've seen an explosion in object storage in the federal space. And object storage is great in its economy of scale and its simple protocol and its ability to store and deliver data on an individual call. But you still have the, not issues necessarily, but physics and mechanics of, well, how do I get stuff in the transmission line? How do I get data in? And how do I get it out? And then the final question, right? What if I decide to get it out and I have every intention of not keeping any scrap of that information in that cloud service? If I want to have some sort of secure removal, secure deletion, overwrite, etc. So very specifically, if I'm going to interact with data in a cloud format, if I'm going to have a lot of data in a cloud format, a lot of times the ingestion mechanism for how I get a large volume of data to that cloud platform can be an interesting topic. So building on what we talked about, figuring out what your data is, figuring out any sensitivity or if and do I want to put this in the cloud? Now that I've figured out the viable data in my organization that I would like to move to cloud, now let me start figuring out some methods for that large piece to be able to funnel it into a cloud structure. And then finally, it's I have a friend who's starting a business right now. He says never get into a business without an exit strategy, figuring out, never do the start without understanding the end from the beginning. What's my exit strategy? If I'm starting a new business relationship with this cloud vendor, and I'm going to be storing these applications, this data on this cloud, how am I going to, one, manage that business relationship, and two, how am I going to, since I'm trusting them with the storage of this data that is my organization's data on their cloud, how do I cut that cord at the end of the relationship? We'd all like to think that every vendor relationship we have will go on in perpetuity forever and that everything will be bright and shiny the whole time. But if I do need to terminate that relationship, what does that look like? Is there costs? Are there end costs at the end of that? How do I get my data back? How do I make sure that there isn't data in the cloud service that I don't want in the cloud service at the end of the relationship? And basically, how do I cut that cord at the end of it? Different things to think about. And then one little third note also in there is, and I've actually been doing quite a bit of this with different federal agencies talking about different cloud certifications and criteria. How do you keep it secure in the cloud? So how do I keep it secure during the migration? So generally there's quite a bit of encryption talk in that area. With some of the federal agencies, there's very specific algorithms that need to be used in that area. How do I segment access to guarantee that if I'm putting a large amount of data into a large pool, that only the people I want to see individual pieces of data can see those individual pieces of data, right? And then finally, something that I keep coming across in a lot of different categories is specifically geolocality. So this comes back to the sensitivity inherent in that data when we talk about the data that you're going to be putting into that cloud platform. Personal identifiable information, PII, is one concern. Maintaining the privacy and integrity of student records or internal financials of the organization would be another concern. International trade and arms regulations, ITAR, I mentioned earlier, stuff that you have as a school, a university, an educational structure that through co-ownership with some other entity needs to maintain, a continental U.S., a U.S. citizen branding around it. So, and further along kind of into this, you know, how do where's the right place to encrypt this data? What's the best place for me to unencrypt this data? Where is it okay for me to have this data in the clear? And I think a lot of this, so again, building up, goes back to an understanding of the data that you're looking to put into the cloud in the first place. So if we look at different clouds and different levels of privacy, I say privacy in quotation marks, if I'm paying someone to host a cloud for me, just me, my organization, and it's truly private, then I can have a high level of security in mind, and I'm not sharing a lot. Now the cost is kind of high because it's built just for me, right? But I can have a high level of privacy understood in that platform. Versus if I'm going to a large public cloud provider where the criteria is you just need to have a credit card and a valid email address to come in, then I need to understand that I'm sharing resources with anyone who fits those criteria. So again, the spend should in some way represent the sensitivity of the data that I'm looking at. And the only way to really understand the sensitivity of the data is to do a thorough, I guess, or have a thorough understanding of the applications and data that you're working with in those categories. And on that, Glenn, I believe I'm passing it back over to you.
Thank you, Tom. And obviously, along with the concept of getting the data into the cloud and out of the cloud, part of the discussion that Tom was just alluding to was, you know, who really owns that data in the cloud. When you look to go to a cloud kind of service, and I'll allude to a external cloud rather than a private cloud, you have to worry about the ownership of that data. And as we go across academic institutions, whether they're K-12 or whether they're university higher education institutions, there's a natural categorization of data that's more or less sensitive. If I'm in research, I may have research that is contract sensitive, like federal government. I may have research information that's academically sensitive, or I may have student information in the faculty side, or I may have financials from the enrollment process that are equally critical. So as you look at that, what data you're putting out there, you really want to make sure that you understand how that data is compartmentalized and who has access to it, and then as you get into that, the bigger concern becomes if you have a project or a person or a set of documents that are out there that need to be removed for whatever reason, whether it's classification or whether it's just simply aging out the data. How do you get that? How do you retrieve that? How do you archive it? How do you destroy it? And all of those things are different requirements around the data that's out there. So who owns that data and how you get it back is really fundamental in working with a cloud vendor. You need to make sure you understand that. And we use the term multi-tenant when we talk about what goes on behind the cloud that you go into. That is, as I look at the structure that you're going into, you may be one of many, many tenants. And how do I make sure that as a multi-tenant that my information is protected appropriately, whether I'm, there's a lot of different cloud worlds out there, and there are different requirements. There's the, if you're working in information justice system structure, there's the IGIS systems. So as you look at what the constraints are, you need to make sure that your data is being defined in a way that meets your requirements of security. Not all data requires the same level of security. So you may have multiple levels as you take different projects or different applications into the cloud. So that, I think that addresses both on the slide stack there. If you look at it, the cloud management discussion, and then the rogue issue, that is, how do I make sure that somebody else is not getting to my data, whether he's an internal administrator or whether he's just somebody that's fishing around in the internet. So those are all at the very high level, those are the things you want to be concerned about around who owns that data. Now, if I step back just a little bit from that, you get into a bigger discussion, which in the academic world, there is a very large discussion right now about student information. Source of ownership can have a different dimension in that a school may own the data in the sense of being the source owner, but in fact, does the student own the data, or does the employee own the data, or does the company own the data, whichever may it be. The big concern here is that as we build out student profiles, and from K to grave discussions, who really should own that data? Should it go into a national repository? There are states that are saying no, our academic information stays within the state. We're very concerned about making it part of a bigger structure. So I don't know where the answers to those things are at, but within your definition, you want to be concerned about the life and expectancy of that data around the ownership, both for the objective you have and for the rights of the student or the client, whoever it is. And then there's one last dimension to this owning the data, and that's the concept of nationalism. There is also another class of requirement that's gaining popularity. For instance, Brazil does not allow any of their information to leave their country. So if you want to do cloud business with Brazil, you had best have a cloud resource in their country, because they're not going to let you put it up in the cloud somewhere else. So now that as I look at making data more available, the mass education kind of structure says, I want to be able to put my course information up universally and get it out to students around the world. That becomes a problem if my country says, like Brazil, that no, that's all the student information resides locally. So that now that I can't produce a mass academic curriculum that goes into Brazil, if I have to register them as an international, who really owns that data, and what's Brazil going to say about it if I have a student down there? So you can see some of the new gray boundaries that are coming up in the sense of where we're evolving with the ownership and title. And I spent time on the student discussion because it's a very hot topic in the U.S. alone, across states right now, to say, do we have a national database or do we have local databases? And we only provide certain information, not the complete profile of the student. So that's one of the big areas of who owns the data. And I wish I had better answers or better discussion points, but in fact, it's very much in a fluid state. So as you move forward from who owns the data to how do we protect it, and in the cloud, there is a lot of complexity there, because if I have an application, parts of that application may be cloud bound, and may in fact be locally bound. I may have my database in my private structure. I may have my web access in a cloud structure. And so now then, if I look at that and say it's hybrid in that I have two different locations, I now have to worry about how do I back that up and make sure it's in sync so that all the pieces play together. And even if I have it all resides in the cloud or it all resides in my private structure, I still have to worry about how that synchronization happens as we build more and more complex applications. Today, our backup method requires that. So, and then the other piece that falls into that is, as we get into cloud definitions, we get into some of the areas of how do I replicate data quickly and how do I get it there. As I get into replication, I get into deduplication mode, which means I have a structure behind there that's keeping track of how many instances of something happens. And then I get into multiple levels of definition. So all of that just adds more complexity to the backup, which brings us to the final kind of thought there, and that's when I get into a cloud backup, I'm really at the supplier's definition level. I can't dictate how they do their backups. I may be able to pay extra for snapshots, but I can't really tell them what their backup method is. They have to tell me that they can conform to my requirements, but I can't tell them because they may be using a common vendor across all of the different hosting services they have. So the issue then becomes, once I do get into that definition, now I've got to worry about what is the recovery method. If I need to recover, will my recovery method be there, be available for me? As long as I have a single vendor, I'm okay. If I start getting into multiple vendor discussions, or if I have a vendor that that moves out of the market, how do I make sure that I can recover data? And now then the other piece is, how much data is there? Is there an archive component that says, I need to go back at a time certain 2 years ago or a year ago and look and see what actually happened in that structure? Can I retrieve that data from the cloud? So there are archiving and cataloging kinds of discussions here around how I do my backup and recovery. So a lot of complexity. Don't make it sound too difficult, but just know that. Think about whatever your compliance requirements are as you think about your backup and recovery methods. And I think, Tom, now I'll let you. Is this one you or is it I?
I think this is me. I think it is. I'm happy to address it. Yeah. So when we're talking about application availability in cloud solutions, it's interesting. A lot of times when we talk about the large public cloud vendors, I'm thinking of the big three. I won't say their names, but I think we could all probably guess who we're talking about. But a lot of times we talk about, we're talking about moving an application to have a web-based application hosted on their infrastructure as a service. We have to re-architect an application to fit that new platform. Often we go from tightly coupled applications to loosely coupled applications in terms of the web server on the platform doesn't talk directly to the app server on the platform, and the app server doesn't talk directly to the database server on the platform. A lot of times we're using queue services where the web server or any web server, because they'll elastically scale up and down, talks to a queue service. The application server grabs these different requests out of the web servers. Any app server can grab it from any queue service. And then likewise, it goes from the application to the database through the queue service the same way. And then it's interesting when we're talking about these applications, there are web services in these major cloud providers, and there are going to be specific RPO and RTO contract requirements around the web services that they provide. There will be guarantees of uptime and minimal data loss, but that's always to a point. Their job is to maintain the availability of the infrastructure because that's what they're contracting to you. And then always in the application, you need to account for your own internal allowable downtime and allowable data loss. So how much time can the actual end users afford to be out of the service and not have access to the service? And how much data can I afford to lose permanently in that way, right? How much data, is it a week? Is it a minute? Is it none? How much data can I afford to lose out of there? And then what would that mean to the end users if they did lose it, and be able to calculate that back and figure out what that means. So there's a couple of different ways to look at it. So cloud could be software as a service, platform as a service, infrastructure as a service. I would say the most important thing is understanding the availability requirements you have around the service that you're going to provide, the application. Understand your allowable downtime for your end users, contract it appropriately with your cloud provider. Understand your allowable data loss. And as Glenn was saying, there are things you could do, have additional snapshots in the cloud service and take additional steps. But understanding your allowable data loss and then taking steps through redundancy, replication, duplication in various forms to be able to maintain that RPO. First and foremost, maintain that you could get that same level of service on a cloud service that you can get in-house if that's the requirements of the application. And then finally, I would say, figure out if it's software as a service, can I contract that? Because they're going to manage all the infrastructure and application availability generally. Then you want to manage your users are not going to be part of their infrastructure. So then it's managing the connection to make sure the users can continue through whatever authentication mechanism it is to get to that application. Because then being out kind of counts as downtime. If it's platform as a service, infrastructure as a service, figuring out what part of the availability requirements fall on your side of the fence as the end user, right? The provider is going to provide the uptime for the virtual machines and the storage in their information as a service or their infrastructure as a service platform. But if you have a machine that blue screens in the middle of that platform and I don't have an ability to restart a resource on that machine or restart that machine from an OS level on that machine, the provider's done their job. They've maintained the availability of the machine. As the end user, and that's, you know, that shared security model, you need to go out there and basically restart or reboot that machine to make sure that it's up to be able to maintain that SLA. And with that, Glenn, I think this one's yours.
Yeah, I think the big thing around the cloud is, in the end, is what does that service level agreement look like? And the first statement to make there is that every provider has their own standard for this contract. And now what winds up happening is it needs to marry to the service level requirement that you have from your service needs to their cloud provisioning. And now then, as you walk through that contract, there winds up being a significant number of issues that you need to negotiate. And so the more you know about SLAs or service level agreements, the more you know about that, and the more your organization is engaged in that, the better you'll understand how tenuous that dance is. So the first thought is to say, if you're new in that space, you probably want to do a kind of a test or beta with a cloud provider and set up some applications just so that you can play with the application and make sure that you understand what you need to be including in your service level agreements. Look at that heavily and work heavily on a profiling definition of what you need. And then as you get into that discussion, understand what you can afford to give away or what you can negotiate as a resource compromise with that provider. Guaranteed uptime is always a discussion, and so getting to 3 nines versus 5 nines, if you've done that uptime discussion, can be very significant in the way providers measure it. So you need to know how they measure the uptime from their perspective, because they have the tools internally, and they will make those determinations based on their tooling and not what you perceive as a consumer. If I follow the slide stack, the entry and exit requirements, that is how to get into the contract, when does it start, what is it all about, and then how do I get out of the contract, are critical. Cloud solutions can be thought of much like applications, but the difference is the cloud may change radically over a period of 3 to 5 years. You know, in a lot of our cases, we put up applications on servers and we expect them to be there for 5 years or 6 years, and we don't think much about that. So look at the transitional or exit requirements. You know, how long do you expect that application to really be in service, and what is it really providing as a service? How to accommodate growth or contraction, whichever the case may be. You know, if I need more resources, is that cloud provider going to be able to step it up, and what is that cost going to be, and how fast can they provide that? If I need to reduce that, let's say I've got a large class load right now, and I need to drop it down to a smaller class size, you know, what is the economic impact on doing that, and can I do that in a timely fashion? Breaches are always a problem. Security is kind of the thing we didn't talk heavily about here, but in the end, make sure that you understand what the liability is if your data is compromised in any way. And same thing with guarantees around retrieval rates and absorbed fees. That is, do they have a set data rate that they expect you to perform against, and are there uplifts, significant uplifts if you exceed that kind of structure. We talked about privacy. Privacy is really fundamental to the underlying assumptions around cloud. That is, the internet is really beautiful if you want to share everything, but if I really want to keep it private, I've got to have my definition in place so that I know who's getting access to that data. Once it gets out, you can't bring it back. And then the next one is location. Sometimes we do cloud discussions because of just for availability and locality. If I'm a bank, to take a radical path, if I'm a bank institution, I probably am worried about a locality that's around my clients. But in fact, transactionally, if I'm doing transactions, I may want to be able to move it from New York to Chicago or from San Francisco to Chicago because of some type of global climate condition, whether earthquake or storm or something. So I may have different reasons for storage locations. So track that as a priority as well, because I know some of the institutes that are out there actually want to get their data out of their data center and into another location, but they don't want it too far away. They want it fairly adjacent. So know what you're looking for there as a service. But the big thing now is if I go to ITIL or one of the standards around data center management now, we're all talking about service level agreements and service level catalogs, and make sure that you're profiling your cloud services in a service level way, and make sure that if you've got hybrid structures, you understand what's on the back end and what's on the front end of that world that you're dealing with. And I think I'll turn it over to Tom now and let him talk a moment about the next thing, and that is disaster recovery.
Yeah, so disaster recovery is another interesting topic when we're talking about cloud. I think most folks that are working in IT today have, the words disaster recovery mean something, right? It might mean backup to tape and recovery in a remote location. It might mean backup to disk and replication in a remote location, and then having access to be able to spool those things out, start them back up, rebuild, and then start at the other side. I think folks have, more as we talk about RPO, RTO, we start talking about global failover and failback and those specific types of scenarios. I think disaster recovery people tend to put out and mentally and a little bit further out of that range. And I think cloud changes a decent amount of that, where it becomes more about the location of the available restore data and your access to it and the access of your users to it and being able to put people back into the application. So when we're talking about either disaster recovery, putting a copy of data to be able to fail to cloud, or if I have data that's running in a cloud to fail out of cloud, becomes this here and there, where you've always want, disasters, natural disasters in the slide tend to be geographic. So you want geographic distance between the two sites, because if you've got a natural disaster that's affecting one site and they're in the same, they're 2 blocks away from each other, that's potentially bad. That's a flood or a storm. You want geographical separation between those two. So understanding your cloud provider, saying that, if your cloud provider says, well, yeah, we keep your data in 3 different data centers, well, where are those 3 different data centers? What's the geographic distance between those data centers that you keep them in? Oh, they're all in this county. Well, how am I going to, if it's a cloud service, maintain geographical separation to another location, to my location, to a third location that I use for DR in a traditional sense? Another thing to think about. So the contract language around that is, I've seen public cloud providers state, yeah, we will maintain an RPO of X by replicating your data between these 3 sites, and we will maintain uptime the same way. That in a lot of these cloud providers, they'll have different major hubs and locations where by contract, they'll say, all right, well, you're signing up for IaaS with this company on this public cloud, and we're going to store your data in this region. And there might be 7, 8, 9 data centers but you sign up by region. You don't say I'm signing up for the global worldwide cloud in a lot of cases. Some you do, some you don't. I don't want to list out specific examples, but certain particular public clouds, if they'll sign on to very specific terms, but all the data centers happen to be that you're signing up for, and that contract happen to be within a very specific area. So have an understanding of that as you're setting things up, and understand if you have critical and vital data that needs to meet certain disaster recovery criteria, that you might need to figure out a mechanism for replication to another geographic area site, either within the same cloud service, one of your own personal data centers, another cloud service, as well as a way to match that back up and be able to restore that at the remote site and grant users access in that other site. And then finally, it's always best, in my experience, when you're doing DR testing, to find a way to test it without putting it in jeopardy. Symantec, I'm a little biased. When it comes to clustering, we have a couple of tools that let you test the viability of the failover and failback of an application without actually putting the application in jeopardy. But yeah, it's always best to test the mechanics behind the failover and failback and actually fail it over and fail back once you're certain it will work okay, as little as possible, because you could actually end up in creating an ensuing outage in some cases. I've seen it happen. And with that, Glenn, I think I'm handing it back to you, but at the same time, up to Q&A.
Yes, thank you, Tom. And Liz, that is the
okay. Here. I have a long question from Deb Rosa. It says, as a technology integrator for K-12, would there be any ways to help students and teachers understand how important the cloud is to them? Webinars for younger audiences, perhaps. Although our youngsters have grown up in a digital world, they do not understand the importance of safety online. Glenn and Tom are stating great facts and strategies for safety, but how do we show the younger generations this info so they can appreciate this info? And she said this is one reason she is here, to share this info, but is there another format that you would suggest for younger viewers?
Tom,
go ahead. Glenn, you go ahead.
I was going to say, Tom, I don't really have an answer for that. You know, I'm sure there are some basic cloud videos out there, but one of the challenges here is getting us to think like them, I think, is the issue, that says, hey, I've got a mobile device and I know how to text message. You know, I've seen 4- and 5-year-olds text messaging now. You know, so from my standpoint, it's like they're already using different forms of the cloud, and I think it's just pulling them into the thought that says it's passing it off to a transaction that's totally transparent, and it's the transparency that's tough to give them the view of. And I don't have a good answer for that. I wish I'd seen a child's video that would do that, but I personally haven't. Have you, Tom?
So I haven't seen anything specific in that category. I do have a funny story. So I have a 8- and 6-year-old. My 6-year-old has all of the necessary criteria to follow in her dad's footsteps and working in IT security and protection. She figured out before I knew about it how to bypass the iPhone passcode to be able to get access to the camera. And I put the passcode in specifically because she was filling my wife's phone up with pictures. She would just take pictures of her feet and pictures of all over the house. But she just blew right past the passcode and accessed the camera without it. So for me, it's tricky. I think that adults and kids look at technology almost in different ways, because as adults, we look at it as this thing that we had to learn, and we almost want to impart some of that in the translation for the kids. But for kids, especially students, I mean, they are growing up digital, and I think they're actually seeing things that we're not. I haven't seen any good content around that specifically, Deb, but I think it's a great idea, and it's one of the things I'm definitely going to take away from the session is possibly running around internally at Symantec and pushing that around to see if we could find some way of working with marketing to generate something like that. I think we're definitely the company to do it as Symantec, to start putting some of that material together. I think it's a great idea.
Okay. So, Deb, you may have just inspired an entirely new marketing campaign for Symantec. Next question, what are some of the international concerns associated with data location?
Glenn, you want me to grab that one since I'm doing a lot of the federal stuff?
Yeah, why don't you go ahead and take a shot at that one, Tom?
Sure. So I work at Symantec, and I do a lot of our cloud-focused things in the federal side. This is Tom Tittermary talking. And I also have the opportunity, which is interesting, to work with our global government team. So to work with folks that represent the government of the UK and the government of Italy and different countries around the world. And there's generally, if we're talking about a cloud solution that we would provide for a government customer, a federal customer specifically, so part of the national government of a nation, we're finding more and more that most nations have a specific requirement around geolocality within the physical borders of that country. And I hate to say it, but especially with recent newspaper headlines regarding specific federal intelligence agencies, a lot of foreign countries are having concerns about storing data in US-based cloud services in some ways. So we're starting to see that the physical location of data, especially to government customers, tends to make a big difference. I've always seen in working with federal customers, if they can't get access to a hard drive so that they can whack it with a hammer, they're not as comfortable as if they did have that access. There's always logical remediation to delete data and destroy data, 7-pass overwrite, using very high-level encryption and shredding the keys. But nothing's generally as comforting or as good for folks as being able to have physical access to the device, and we're just not seeing that in most cloud. And I'm seeing, especially I'm seeing that very specifically with intellectual property, very, very sensitive intellectual property with major companies, and I'm seeing it with sensitive data in government agencies as well.
Yeah, Tom, we're actually seeing that right now with the telephone as well, in the sense of the international issues where the European market has a very different perception than the U.S. So as we look at the international discussion, there's just so many dimensions to it, and really it is country specific in itself. The other thing I wanted to jump back to Deb's question again and say one of the things that sometimes we lose sight of is are we talking about for children? Are we talking about the cloud as the cloud? Are we talking about the cloud as the internet? And is the internet the cloud, or is the cloud the internet? And I don't know that there's an answer there, but I just want to throw that out and say, what is the dimension of what we're talking about really as an applicable item? Is it really about the cloud, or is it really about children's perception of the internet? So anyway, I don't know if there's an answer there, but I just wanted to throw that out for the audience. Thanks. Anything else?
Okay, I just had a participant send me some links that I shared with everyone via the chat function, a couple links on related to teens and children and that sort of stuff. So you can check out the chat.
Yeah, I was going to volunteer that if you do a quick web search, there'd be a lot of links. But my concern is that somebody go out there and search and find something bad, and then I would say, boy, that was a bad answer. So I didn't want to do that. But yeah. Thanks to whoever sent those out, because there are some good webs out there. I know some of our partners in technology have already done some great sessions, and in fact, Symantec has done security in the education environment as well. We do seminars or sessions with kids, etc., to help raise awareness both on the security side and the data protection side.
Okay, here's a question. Do you implement additional security policies for mobile devices that have access to sensitive data in the cloud?
Tom, you want me to take that one for the moment?
Yeah, sure.
All right, I'll go ahead. What happens is that there are, trying to stay away from Symantec as a discussion here, but there are different vendors that have products out there that you can wrap it around an application and pass the data out to the device, and when you're done, it will actually delete that data. So there are different types of tooling. One is, if you have security on your phone and you enter the wrong password too many times, it should wipe itself clean. Second is that if it's the application, well, then you want to get one of those application wrappers that will delete itself after use. So yes, there are solutions out there. Now you get into a authentication discussion here very quickly that says, for the application you have to authenticate yourself yet again, different than your phone or your mobile device. But yes, there are devices out there or solutions out there to give us that intermediate security, and actually some of your commercial vendors are using that to provide services to you today. Any other comments, questions?
Sorry, had to unmute. One last question, and can you explain cloud elasticity and how it is managed?
Repeat that.
Can you explain cloud elasticity and how is it managed?
Do you want me to grab that, Glenn?
Go ahead. Go ahead. Yeah.
Sure. So one of the great use cases around why cloud that I've found is elasticity, right? So if you're running an application on a major third-party infrastructure as a service cloud provider, and you can actually run your application with exactly the amount of infrastructure that it requires based upon the number of requests you have in that 30-second period. You can add web servers, you can add app servers, you can remove those same entities based specifically upon the demand. So a lot of the biggest, Netflix is a great example. They don't have a static infrastructure that's always there to serve the user community. They rely upon those types of services to be able to scale up and scale down their infrastructure, depending specifically upon the demand of the user base. And the way they do that is they can just dynamically add web servers and app servers because they have loosely coupled the applications. So web server A does not talk to app server B. It just feeds things into a queue service. And then the app server is pulling things out of that queue service. The queue service is just one of the general cloud services. It's not specific to that customer or application. And the database on the back end, a lot of times the cloud provider will manage the back-end infrastructure of most of those providers offer a relational database as a service offering as well. And then most of the time they'll just store most of their files that they need or a lot of their big data storage in a cloud object storage platform. So, on Monday at 4 in the morning, there's 5 users requesting, not very much. All right, well, I have one small web server, I have one small app server, and I'm using very little on my database, and I'm not really accessing my storage. But on Friday night at 8 o'clock, somebody like a Netflix or a media provider might need 20,000 web servers, 22,000 app servers, and a massive amount of interop between that and their database, tons of files coming in and out of object storage. But the ability to scale up and scale down based upon the incoming requests is generally how I'm talking to cloud elasticity and making that description.
Yeah, and Tom, there's yet another dimension to it. If I think internationally rather than locally, there's a different elasticity that says I can have Internet of Things that give me a presence in Asia, a presence in Europe, and a presence in the U.S. as an example, and I can replicate that data out there. And when somebody goes to get it, I actually point the end user to the local copy rather than the around the world copy. And that's a different form of elasticity. But if I'm in the commercial world or if I'm in the public selling mode, well then that elasticity is really important to me. Probably if I'm in an academic world, when I'm dealing with a state or a local community, I probably don't need that type of elasticity. So Tom's type of elasticity is really important. I need to expand it or contract it for a particular period of time, where internationally, that's the reason I was struggling when I started this discussion. Internationally, there is an elasticity around providing data where it's needed, when it's needed, rather than trying to bring it all back to one spot. I don't know if that answered the real question or not, because there's so many different dimensions of elasticity. It can be around user expansion, it can be around data expansion, it can be around application expansion. But I hope that answered a little bit of the question. Do we have another one? Time.
We are out of time, unfortunately. So if anyone has additional questions, they can email me and I can forward them on to the appropriate person. My email address is lglome@eschoolnews.com. If anyone has questions, they can email that. You also, and as I said before, you will get a follow-up email with a copy of this presentation and the slides, and that will also include my email address if anyone needs to answer any questions. So with that, thank you guys for attending, and expect that follow-up email in the next 2 business days. Have a good day.
Thank you much.
Thank you, Liz.